Let's move on to number 16. All right, number 16 is one of those problems that generally has a couple of sections along with it, but when I copy the question, oh well, all I saw was this part. So I should have looked a little closer. All right, let's get it up. There we are. All right, the rectangular shipping crate, like this figure, has a diagonal measurement from, let's see where it's from the lower back corner to the upper front corner of 52 inches. If the longest side is 4 times the shortest side, this side right here, and the height, which is the height, that's the shortest side, and the third side is 4 inches longer than the shortest, even though it didn't say inches, and the height is x, what is a function to represent the volume of the crate? All right, remember that volume of any rectangular prism is equal to length times width times height. And they said the longest side, which is this length, is 4x. The height is x. How wide is it? The width is evidently the third side is 4 longer than the shortest. So that means shortest side plus 4. It didn't say 4 times, it just said 4 longer. So that means x plus 4. And this could typically be a multiple choice question that you might see on your test, because you will have multiple choice questions and lots of them. And you'll just pick the volume formula. That's all there is to that. Let's look at 17 now. All right, 17 takes us into chapter 4, where we start dividing polynomials and trying to figure out roots and all the possible rational roots. So we're going to complete this quotient. There we go. Find the complete quotient when p of x is divided by the binomial following it. All right, so we've got this polynomial and we've got this binomial. So we set the binomial equal to 0, and we find out that our 0 is -1. This is what we would call our k value when we use the remainder and factor theorems. So we're going to take that -1 and put it right here. And then we write out all the coefficients in descending order. So 2, 3, 4, and -10. Now, when I do synthetic division, which is what this large L is for me, I use a symbol like this, where the 0 goes here and the coefficients go there, and I begin by moving down my first term, which is a 2. Then I multiply everything that's on the outside here. So I say -1 times 2 gives me a -2, and then we add straight down. That gives us another 1. 1 times -1 is -1. Add straight down, and I get a 3. 3 times -1 is -3. Add straight down, and I get a -13. Now, when I get to this final number, this is my remainder. And what do these other random numbers mean? These are the coefficients of my answer. So my answer begins with a coefficient of 2. We have a variable x. But what is my exponent? Since my original exponent was x cubed, my answer is going to begin as x squared. Why? Because I'm dividing x cubed by x, which gives me x squared, because you subtract the exponents. This next one is a plus 1x. It's always in descending order. Plus 3. And then since we have a remainder of -13, I could write plus -13, but I'm going to write minus 13 over what I divided by as a binomial, x plus 1. And this is how you write the quotient and the remainder. This is our complete quotient. Sometimes you have a remainder of 0, and in that case, you don't have to write anything over the binomial, just the resultant polynomial. And that's all you have. Let's move on to number 18. Another synthetic division problem. What good practice for us. Let's factor p of x into linear factors, given that k is a 0 of p. Now remember before that I referred to k as that -1 I got. So I'm going to take this k and put it right outside here. This time my L is looking a little crooked, but it's still the same L. So let's put our coefficients down. We've got 4. And anytime we look to the next exponent, anytime we don't see it, like it should be 3, 2, 1, and then 0 or no exponent at all, no variable, If we are missing one of those, we have to put a 0 in as a placeholder. So we've got 4, we've got 35, we've got 84, and we've got 45. And we've got all of our terms accounted for. Start with the 4, bring it down. 4 times 5 is negative 20. That's a negative 5, so it's negative 20. Negative 20 plus 35 is 15. 15 times negative 5, if I'm not mistaken, is negative 75. I'm going to go with my gut on this, but I'll check it in a moment with the calculator. And then when we add this one straight down, it should be a 9. And then 9 times negative 5 is negative 45. It seems to have worked out quite well, because they told us in the notes in the very beginning, our directions, K is a 0 of P. If K is a 0, that means that we're going to get a 0 for our remainder. How wonderful. All right, so this minus 5 is one of my factors, so I can go ahead and write x minus negative 5, or x plus 5 in a few minutes. Now let's write out what these numbers that are hanging underneath here mean. Remember, it's 4 as our first coefficient, x. We started out with x cubed, so this is going to be x to the second power. And then, plus 15x plus 9. Now, we've got to factor this. We've got to figure out, what multiplies to give us a 36 and adds to give us a 15. So remember my secret method in class. We've got an x here. We've got to figure out what multiplies to give us this number times this number, the a times the c, which is 36, but what adds to give us 15. So let's think. 36 has factors 1 and 36. That doesn't work. 2 and 18. That's close, but it doesn't work. 3 and 12. Now we're cooking with gas. Because 3 times 12 is 36, and 3 plus 12 is 15. Now, old high school students of mine, not the ones I've got now, would say x plus 3 times x plus 12 and go on about their business. But that is not what we're going to do. We're going to write that down, but we know that we can't multiply this and get 4x squared plus 15x plus 9. So we take this 4 and we divide it into both of these, terms here, the 3 and the 12. Now 4 doesn't go into 3, and we could leave it like this, or we could swing that 4 right out to the front, and it gives us 4x plus 3. Now 4 does go into 12, it goes into it 3 times. So it'll go into it that many times. And that's our other, set of factors. And as we bring this guy right on down, because he's already one of the zeros that we just discovered in synthetic division, but they told us, we can write him as x plus 5. Now, as I've mentioned to you in class, if factoring is not your forte, use the quadratic formula. Complete the square. Graph the function. Whatever method works for you is what you need to do. And I will see you in the next review section. Good luck with your studying.